Hello everyone, welcome back to Math Online. I'm Mr. Solis, and on today's video we will talk about section 3.5, graphing linear equations in slope-intercept form, day number 3. Today's objective is students will be able to identify slopes and y-intercepts of linear equations and graph linear equations in slope-intercept form. And remember that the slope-intercept form is just the equation y equals mx plus b. All right, with that said, let's move on to the next slide. All right, so slope-intercept form is the equation y equals mx plus b. And one of the things that I want you to know is that the m, as we can see here, the m represents the slope, m is the slope, and on the other hand, the b represents the y-intercepts. So the slope of a line is m, the letter m, and the y-intercept of a line is the letter b. The y-intercept is always placed on the y-axis. There are two axes on a coordinate plane. There's the horizontal line, which is known as the x-axis. Now there's a vertical line going up and down, which is known as the y-axis. Well, your y-intercept is always placed on the y-axis. As you can see on this picture, we have our b value here, the letter b with the dots, because that's where the y-intercept is located at. Okay. All right. With that information, let's go ahead and move on to the next slide. All right. So on this slide, we're going to be looking at example number 1, and the instructions tell us to identify the slope and the y-intercept of each linear equation. So they gave us an equation, and what we want to do is compare our linear equation to the slope-intercept form, y equals mx plus b. Y equals mx plus b, where m represents the slope and b represents the y-intercept. Notice how these y's are matching, the equal sign is also there, the x and the x is there, the plus sign is there, and of course, if all of those other variables and signs are matching, then m will be matching or pairing with -3, right? So the slope in this case is -3, and as we can see, the slope is always in front of the x. In this case, -3 is in front of the x. So our slope in this case is -3. So you could either say m is equal to -3, or I'm going to say or we can say that m is equal to -3 over 1. Why did I write the slope as a fraction? This is important. The reason why I want you guys to practice writing the slope as a fraction is because we're going to be graphing, and we want to have the slope as a fraction because we will be using rise over run in order to create more points. And we'll talk more about that in just a second. So the slope is -3 over 1. We'll conclude it at that. Okay. Why we're using fractions? To make it easier to graph the equations when we get to use the slope rise over run. Okay. Now, the y-intercepts should be our b value, which is pairing or matching to the 5 here. So it's not just 5, but it's +5. So I'm going to say y-intercept is 5, or we could have also said b is equal to 5. Either one works. Okay. All right. So let's move on to the next slide. All right, guys and girls, here we go. Steps to graph linear equations in slope-intercept form. So step number 1 will be done for you. All of your equations will be in slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. Okay, you have to be able to identify those two things, the slope and the y-intercept, in order to graph an equation. So with that said, this will be done for you. So just identify the slope and the y-intercept. That's all you got to do for step number 1. Now, step number 2, we got to plot the y-intercept on the graph. The y-intercepts is known as the starting points or the initial value. Why is it known as the starting point or the initial value? Well, because that's the first thing you want to plot on your graph. That's the first thing you want to plot on a coordinate plane, right? So that's why it's called the starting points or the initial value. So we will plot the y-intercept on the graph, and we need to understand this as well and not make a mistake. The y-intercept is always placed on the y-axis. The y-intercept is always placed on the y-axis. Now, let's move on to step number 3, starting at the y-intercept. So now that you've plotted your y-intercept, you have a point on the coordinate plane, then you want to use the slope listen to this, you want to use the slope to find other points, or in other words, you want to use the slope to create more points, right? And once you created more points, several more points, maybe 3, 4 more points, 5 more points, you want to connect all of these points together to form a line. Your line should be a straight line. Since we're talking about linear equations, linear equations means that you're going to have a straight line. Let's move on to graphing, because that's the main concern today. Okay, here we go. All right, so we're looking at graphing the equation y equals negative 2x minus 4. So as you can see on this picture here, we have m representing the slope and b representing the y-intercept. Once again, notice that the slope is always in front of the x, so that's important. So we know that the slope, before we graph anything, we want to make sure that our equation is in slope-intercept form. Yes, it is. Y equals mx plus b, as we can see. So we need to identify the slope and the y-intercept in step 1. So slope m, or m, we know that the slope is always in front of the x, so in this case it's negative 2. And remember what I said, I want you guys to write the slope as a fraction. So negative 2 can be written as a fraction by writing negative 2 over 1. And I want you to relate the slope with rise over run, because the slope is represented by rise over run, or m equals rise over run. So rise over run. And if you guys remember, we talked about this, the behaviors of the rise, the behaviors of the run. The behavior of the rise is moving up or moving down. Usually the run, when you're graphing, it will be moving to the right side. Okay, but of course we want to be precise, right? We want to focus on this particular slope. So we know that the rise will have a behavior of moving down, not up, down. Why? Because our number is negative. If the numerator on the fraction is negative, then the rise will have a behavior of moving down 2 units in this case. And the run, of course, will always move to the right. So here we go. Now, we're going to move on to identifying the y-intercept really quick. So the y-intercept in this case would be our b value, which in this case is negative 4. So now we're going to get to step number 2. Step number 2 asks us to plot the y-intercept on the graph. So here we go. Negative 4 is our y-intercept. So therefore, we talked about earlier that the y-intercept is always placed on the y-axis. So we have to make sure that we understand which one's the y-axis. The y-axis will always be the vertical line going up and down. That'll be your y-axis. So now all you have to do is identify the y-intercept, the value of the y-intercept, which in this case is negative 4. So negative 4 is right about here. So I'm going to make a dot at negative 4. And this concludes step 2. Now we're going to jump into step 3. And step 3 asks us to, starting from the y-intercept, which this is the y-intercept, we will start from here and we will start using our slope to create more points. Okay, so we want to create more points to eventually have a line. So here we go. We're going to use our slope. Our slope tells us to move 2 units down and 1 unit to the right. So let's go ahead and do that. 2 units down, 1, 2. And from here, I'm going to move 1 unit to the right. And there it is. So 2 units down, 1, 2, 1 unit to the right, 1, there it is. 2 down, 1 to the right. Now that you created more points, what you want to do is connect these points with the line, with a straight line. So you could use a ruler to form your straight line. In this case, I'm going to use a tool. You'll see, there it is. It's not that straight, but let me fix it. Let me just fix it a little bit. Whoops. I'm not fixing it. Now I'm fixing it. There it is. Now I need to fix the bottom portion. There it is. The line needs to be crossing through these points, right? Now I can actually expand this line if I wanted to. So what you want to do here also is include arrows. You want to have arrows on the ends of this line and arrows on the ends of this line. Why do we want arrows? Well, the arrows indicates us, the arrows tells us that the line goes forever and ever in both directions. Okay, so that's what the arrows tells us, that the line goes forever and ever in both directions. All right, on example number 4, I really want you guys to give it a try on your own. So go ahead and pause this video before you watch me and listen to me solving this problem. All right, here we go. Hopefully you had a chance to try this example on your own. So first step is to identify the slope and the y-intercept. So let's start off with the slope here. So the slope would be 2/3 remember that the slope is always in front of the x, and in this case, since both of these numbers, the numerator and the denominator of the fraction, are positive, we know that the slope is a positive. So even before graphing the equation, we know that the line must rise from left to right. So keep that in mind, okay? So if your line does not rise from left to right, then we did something wrong, okay? That should be a red flag right away. So remember that m is represented by rise over run as well. So m is equal to rise over run. Whoops. Let me go ahead and fix that. So rise over run. So 2 over 3, rise over run. And notice how the behavior of the rise, we talked about this, moves up or down. And the run is always moving to the right. But in this case, the rise, since it's a positive number on the numerator, it's going to be moving up over the run, which in this case it's also a positive number, and it's always moving to the right. Now that we know the behavior of our slope, we will be ready to use our slope to find more points. But before we do that, let's go ahead and identify the y-intercept. The y-intercept will be 1 in this case. Remember, the b value is the y-intercept. In this case, it's 1. The y-intercept is always located, or the y-intercept is always placed on the y-axis. So the y-axis is this line, the vertical line going up and down, and the positive one is located right about here. So now that we placed our y-intercept on the y-axis, we want to use our slope and create and draw more points. So that's what we want to do now. We're going to use our slope to create more points. We're going to use our slope to draw more points on this graph. Okay, so here we go. So we will use our slope, which tells us to move 2 units up, 1, 2, and 3 units to the right. 1, 2, 3. Make a dot. Then I'll do it again. 2 units up, 1, 2, and 3 units to the right. 1, 2, 3. There it is. And of course, you can keep going and adding more points. I'm gonna leave it at 3 points. So then I would grab my tool, and I would draw a straight line through these points, as you guys can see. And let me go ahead and fix this. It's not that straight. Now it is. All right, now I could expand this line as well if I wanted to. And don't forget, something that I mentioned before, you need arrows on both ends, indicating that the line goes forever and ever on both directions. That's how you graph linear equations. Hopefully you enjoy this video. But before we close our session, I do want you guys to work on the exit ticket. The exit ticket, you can answer the exit ticket on the comment section below. So go ahead and answer the following questions in complete sentences. Question number 1, where do we place the y-intercepts of a linear equation in the coordinate planes? In other words, in the graph paper. So question number 2, why is the slope important when graphing linear equations? We use the slope to do what, in other words, okay? That's your question there. So go ahead and once again answer these questions in complete sentences down below on the comment section. And if you enjoyed this video and this video was helpful, don't forget to drop me a thumbs up. And remember, we teach a new lesson like this one almost every single day. I'm Mr. Solis, and I'll see you on the next one.